Hello everyone, welcome to my channel. Today we are going to take a wild ride along the number line. No seatbelts required, only your curiosities. We will learn everything that you require to solve questions related to number system. So ready to become a number ninja, right? So you all know about number line, right? You in the previous standards you all have already learned about number line. In number line you mention the specific type of number in specific way, like you represent the positive numbers on the right side of number line, like 1 2 3 and so on. In between you mention a zero, and in the negative side in the left side you mention a negative numbers. So it's gone up to minus infinite, it goes up to infinite, right? Now we will classify the different types of numbers, like we will classify the different types of people in the party. Okay, so our first type is natural number. Natural numbers. Now what type of numbers comes under natural number? We all know that it starts from 1 and go on up to infinite on the right side. So we'll write 1 2 3 up to infinite. Okay, sometimes you saw that people mention it n instead of infinite. That means goes up to n, right? Ever imagine why it's never ends? Because no matter how big the number is, you can just add one and get another number, that is natural number. Okay, so we got one type of number, that is natural number, in which all the positive integers came. We represent it as a n because natural number, so we represent it as a n. You have to remember this sign for particular numbers. Okay, now there is our silent friend zero. Because it is silent doesn't mean, that does not mean we will ignore it, so we will have to add the zero also. Now then another type of number came, that is whole number. In the whole numbers, which type of number comes under the whole numbers? All the natural number, just we have to add zero. So 0 1 2 3 up to infinite, or we have represent it as a n. Okay, you have to mention this curly bracket. This represents a set of a particular type of number or anything, so we will represent it as a curly bracket and in between comma of every numbers. Okay, now if someone asks you what is the smallest natural number, or if someone asks you where the natural number starts, what is start point of natural number, you have to just answer 1. In the whole number the answer is 0, right? And the by w you represent it as a w, so you have to remember this w for a whole number. In w, what type of number comes? All the positive numbers and 0, right? Now the third part, all the negative friends. So if we combine all negative, 0 and positives, then it becomes integers. In integers, what type of number came? The number you can see on the number line, -3, -2, -1, 0, 1, 2, 3. Both the side it goes up to infinite, right? Now in the integers, what is the sign that we use to represent integers? It is z, and here it is I, and you are representing it as z. The z is for zahlen. In the German language, zahlen means to count, so we represent integers as a z. Okay, now apart from these numbers, what about fractions that you have learned earlier? Like you can write 1.5 here, you can write 1 by 2 here. This all these types of number that doesn't come under these three types. We have to do something for this, and here comes our fourth type, and that is rational number. And for rational numbers we have to write a small definition. Any number that can be represented in the form of p by q, numerator and a denominator, that we called a rational number. But there is small condition, we have to mention what is p and q. So p is any integer, you can write anything from this as a p. And what is q? q is any integer apart from 0. So we can write it as a q does not equal to 0. This is the condition you have to remember to identify whether the number is rational number or not. Like here I will give you 4-5 examples and you will identify whether the number is rational number or not. Okay, now see, here is 1 by 2. Does it in the form of numerator and denominator? Yes. Does in the denominator have contains 0? No. Here is a 2, so yes, it is rational number. We have to just show that in the numerator and denominator there should be an integer, but denominator should not be 0. So if you have to check whether the number is rational number or not, just go on the denominator and check whether there is 0, then say this is not rational number. If there is not 0, then check if numerator is integer or not. In the denominator there is 6, this is not 0, so we have to check numerator, that is minus 12, that comes under integer, so it is a rational number. Now here 12 upon 0, in the denominator there is 0. We all know that 0 cannot be shown as a denominator, so this is not rational number. Here comes 0 under 12. Now in the denominator there is not 0, so we have to check numerator. In the numerator there is 0. Now 0 by 12, 0 comes under integers. In the numerator you can write 0, there is no problem. So this is a rational number. So we have learned all 4 parts, that is natural number, whole number, integers and rational numbers. Now by which sign we represent the rational number? There is q. Q comes from quotient, right? Now we will learn about the relationship between these 4 numbers, right? By one example. Let me say this box represents a small village named Rampur. This box represents the people that are living in this village named Rampur. Now I will make another box. This box represents a people that are living in the district named Ayodhya. Right? Now there is another box that is representing the peoples that are living in the state named, we all know, UP, Uttar Pradesh. Now we have another box that represents the people that are living in this country named India, right? So we call this figure as a Venn diagram, right? By the Venn diagram you can give the answers simply. Like if I ask you that all the people that are living in Rampur also living in state Uttar Pradesh, is it right or wrong? Because the state village Rampur comes under the state UP, so all the people living in the Rampur also comes under the people that are living in Uttar Pradesh, right? So this is right. If I ask you all the people that are living in district Ayodhya also live in country India, so it is right because Ayodhya comes under country India, right? Now if I ask that all the peoples that are living in India also live in Rampur, that means if I am staying in Gujarat, I also comes in Rampur. If you are staying in some other district like Rajasthan or Maharashtra, you also come in Rampur. That is not right, obviously. So if I ask you a question this direction, like all the people that are living in Rampur also live in Ayodhya, then it is right. All the people that are living in Rampur lives in Uttar Pradesh, that is also right. All the people that are living in Ayodhya that lives in India, that is also right. But if I ask you question reverse direction, that will be not true, right? Now what if I just change a name? Here I will write N, here W, here Z, and here Q. Then the same rule will be applied for this also. Here N is natural number, W is whole number, Z is integers, and Q is rational numbers. So if I ask you all the numbers that comes under natural numbers also comes under whole numbers, then it is right. Right, you can see here all the numbers that comes under natural number like 1, 2, 3 and so on also comes under whole numbers. So here you can see whole number also contain 1, 2, 3 and go on. Right, now if what if I ask all the number that comes under whole number also comes under integers, you can see here all the numbers that comes under whole numbers are number starts from 0 and go on up to 1, 2, 3 and infinite. That also comes under 0, 1, oh, 0, 1, 2 up to 3 infinite. So integers contains a whole number, right? So in this direction, if the question is asked, the sentence will be true. Now what if I ask you in the reverse direction, like all the number that comes under integers also comes under natural numbers. All the number that comes under integers also comes under natural number. Will it be true? No. You can see here that natural number only contains a positive integers, but in the integers we have 0 and also negative numbers that does not come under natural number. So if I ask you in the reverse direction, that will be false. Now if I want to write it in a single line, I can represent it as a n w z q. In between I draw this sign. Oh, right, this sign represents that n is subset of w, w is subset of z, z is subset of q. Okay, now we will learn about how to represent the rational numbers on number line. What I am saying is, if you have ever asked to represent a numbers like 1 by 2, 2 by 4, 4 by 8, 12 by 24, mention these numbers on or represent these numbers on number line, what you will do? So for a 1 by 2, you all know that this is 0.5 and you represent 0.5 in exact between 0 and 1. So here I already mentioned 1 by 2. Now for the 2 by 4, if you solve this further, 2 by 4 also become 1 by 2. So we have to write 2 by 4 here. Now for 4 by 8, also the same process. We have to write it here. So if in this case, if we representing all this number on number line, so there is for every particular point on a number line we got infinite numbers. That will be difficult us to represent it on a number line. So we will use a method that is called, we will only mention numbers that are co-prime for numerator and denominator. In other word, I can say the numbers that are type of p by q, then if I have to represent it on number line, then there is one condition, and condition is p and q should be co-prime. Or in another word, co-prime is that they have only one common factor, and that is 1, right? So if I have to mention 3 by 4, check whether 3 by 4 is co-prime or not. Yes, 3 and 4 does have only one common factor, and that is 1. So 3 by 4 is a co-prime. 3 and 4 are co-prime numbers, so we directly represent 3 by 4 on number line, right? And all this number we can write equal to sign in between, because after further cutting the all numbers become 1 by 2, so they all numbers are same. Okay, we call it a equivalent rational numbers also. Now all the rational numbers come integers, whole, natural numbers. Now we will see the examples. Okay, now here is our first example. We have to show that the statements given here are right or wrong, true or false, and we also have to mention why it is true or why it is false, right? Every whole number is a natural number. Remember the story of our village, district, state and country, or you can just show it here. What I have just said is every whole number is a natural number. Now by saying whole number I means w, and by saying natural number it means n. This is asking that every whole number is a natural number. We all know that if the question is asked in this form, then it will be true. but it is asked in reverse direction, that every whole number is a natural number, then it will not be true. If you want to imagine or visualize this, you can write it here like every whole number. So we represent whole number by 0, 1, 2 and infinite is a natural number. We represent natural number by n. It starts from 1, 2, 3 up to infinite, right? And this is saying that every whole number is natural number. There is a 0 in whole number, that does not comes under natural numbers, right? So our first statement becomes false. And why it is false? Because 0 is whole number, but 0 is not natural number, right? If you have remembered all the notation for different type of numbers, then the question will be very easy. You just have to remember this line. If the question is asked in this direction, then it will be true. If the question is asked in reverse direction, then it will be false. But you also have to see the language of the question also, right? The second is every integer is a rational number. Now integer means in our language integer is a state, that is UP, and asked is integer is a rational numbers, that means UP comes under India. Then we all know that it is right. So the statement is true. Now we have to mention why this is true. Let me write integers here. -3, -2, -1, 0, 1, 2, 3 up to infinite. Now to prove that these all numbers comes under rational numbers, I have to mention it as a form of p by q, right? What I have to do is I have to mention all this number as a form of p by q. So let me do this. Let me take any number from this. Like I will pick some positive number. This is true. If I want to mention 2 in the form of p by q, what just I do is write 1 as a denominator. Does it affect on 2? No, because if you write 1 in the denominator, the value of numerator will not change, right? So we can represent 2 as form of 2 by 1. Now it is in the form of p by q, where q does not equal to 0, right? So it will become a rational number. Now here comes for 0. For 0 you can write anything under 0, the value will be 0. But here I am writing 1, 0 by 1. That is also a rational number. It is in the form of p by q, where denominator is not equal to 0. That is the thing we have to remember. Now for a negative number, like I am writing -2. So -2 I can represent -2 as -2 by 1. In here denominator is not 0, it is 1, and it is also in the form of p by q. So this is also a rational number. So in this way we can represent any integers in the rational numbers. So the question is true. Now we have to mention the reason for this. Now remember, if you ever have to give a reason, if the statement is true, then you have to give reason for all the members here, all the numbers. Now if the statement is false, you just give one example that is false for the statement. Here we give only example for 0. Now here we have to give a general answer. So here what I write, for any integer m, we can write m by 1, and that is rational number. Here is the reason that every integer is rational number. You can change the language as you want, but the meaning should be remain the true. Meaning should be remain the same, or else you can write anything. Now the third sentence, every rational number is an integer, comes here. Rational number, that means q, integers, that means z. Every rational number is an integer. The question is asked in the reverse direction. We all know that it will become false. but we have to give an example that does not goes with this sentence. So that in the reason you have to mention any number that is a rational number but not an integer. You can give any example. I am giving the example as 2 by 3. 2 by 3 is a rational number. We all know that it is in the form of p by q and the denominator is not equal to 0. 2 by 3 is rational number, but 2 by 3 is not integer because we all know that in integers the numbers that contains fractions does not come. So 2 by 3 is not integer. So here is our reason. You can give any example that is a rational number but not integer, right? So this is the simple way, the simple trick. By remembering this, you can answer this type of question. This type of question will come in your exam. It is for sure, right? So it is better for you to remember this. This is a definition for rational numbers. A number that can be written in the form of p by q, where p and q are integers and q does not equal to 0 is rational number. What is rational number that you remember? That is written in the definition. You can change the language, but the meaning should not be changed, right? Now we'll go with to the example number 2, right? Here is the question for example 2. Find 5 rational numbers that comes between 1 and 2 in the number line. As we all know, here 0, 1, 2, minus 1. This direction is minus infinite, this direction positive infinite, right? There are infinitely many numbers that comes under 1 and 2, and also that there are rational numbers, right? Now I have to just find 5 rational numbers that comes under 1 and 2. See, in your textbook there is a two way to find rational numbers between 1 and 2. The first way is in the number line. If you have to find a number that is exact between those two numbers, like I am saying that I have to find a number that is present exactly between this 1 and 3. What I am saying is I have to find a number that is exactly between this 1 and 3. What I have to do is just add those two numbers. I have to find a number between 1 and 3, so I have add 1 and 3, and in the denominator just write 2 divided by 2. So 3 and 3 plus 1, it becomes 4 divided by 2. The answer will be 2. You can see 2 is exactly in between 1 and 3, right? This is the method we use to find the numbers that comes between 1 and 2. If I zoom the number line, I write 1 here, 2 here, okay? What I have to do is just add these two numbers and divide it by 2 to find exactly the number that comes between 1 and 2. I am adding 1 and 2 and dividing it by 2. That gives me the result 3 by 2. So 3 by 2 will come exactly between 1 and 2. So I got a first rational number that comes between 1 and 2. Now for second number, now I will find a number that comes between 1 and 3 by 2. That also comes between 1 and 2. So answer will be, I have to add 1 and 3 by 2 and divide it by 2. Here's 2, we have to take 2 as LCM. So our further answer will become 2 plus 3, that is 5, and this 2 and 2 multiply, so it will become 4. So here comes 5 by 4, that comes exactly between 1 and 3 by 2. Now to find another, we have used 3 by 2 and 2. We will use 3 by 2 and 2 to find exactly number that comes between 3 by 2 and 2. We add 3 by 2 plus 2 and divide it by 2. Now by taking LCM as 2, we get 3 plus 4 by 2 as LCM, and the 2 that we are dividing. So our further answer will become 3 plus 4, that is 7, and this 2 and 2 will be multiplied, so it will become 4. So our answer will become 7 by 4. Now we got 5 by 4, 3 by 2, 7 by 4. Now to find further two more numbers, you can use these two numbers to find number between these, or these two numbers, or these two numbers, or these two numbers. What you have to do, you can find the other two numbers also. This method is very lengthy, right? So we will use second method. But the concept you should remember, that to find a number exactly between two numbers is add those two numbers, simply add those two numbers and divide it by 2. This will also be used in another chapter. Now the second method is to find 5 rational numbers between 1 and 2 in number line. That means I have to find 5 points between 1 and 2 and give it the value that it contains, right? So what I am doing is, this is one stick. If I make a 5 cut into these sticks, how many parts become? 1, 2, 3, 4, 5, 6. 6 parts becomes. We will use these concepts to find the numbers between 1 and 2. What I am doing is, for 1 and 2, I have written 1 and 2 here. Now here I have to find 5 rational numbers. So by cutting 5 times, I will get 6 parts, same as this type. Here I have given 5 rational numbers, so I will multiply and divide it by 6 and 6. Also for this, multiplying and dividing by 6 and 6, this will become 6 and this will become 6, because by multiplying numerator to numerator, denominator to denominator, for this 6 to the 12 divided by 6. Now do not cut it further, otherwise it will become 1 and 2 only. Okay, so we have to keep this. This is 6 by 6, this is 12 by 6. Now write all the numbers that comes in between, like 7 by 6, 8 by 6, 9 by 6, 10 by 6, 11 by 6. These all numbers are rational numbers that comes between 1 and 2, and we got exactly 5 rational numbers. Okay, now if you don't want to remember this, like for if we have to find 7 rational numbers, then I have to multiply and divide it by 8 and 8. Now if you don't want to do it, there is another trick. Like I have to find 7 rational numbers between 11 and 12. In this method, you have to do is, here that is mentioned is, we have to find 7 rational numbers, so we will multiply and divide it by 8. Also we will do the same thing for this. Now if you don't want to do this, the concept is you have to multiply and divide it by a bigger number from this. Like here it is 5, so we multiply and divide by 6. Now here is 7, so I will multiply and divide by a bigger number, that's 7. And the easiest way will be for me is dividing and multiplying it by 10. Also for this side, multiplying and dividing it by 10. I just have to multiply and divide the number that is bigger than these numbers, right? Then the easiest way is 10, so it will become 110 above 10, it will become 120 above 10, right? So it will be easy for us. Now if I have to find 32 rational numbers between 11 and 12, what I will do is, the easiest number that is more than 32 for multiplying dividing is 100. So I will write 100. To multiply and divide, the number will become 1100 by 100 and 1200 by 100. Now there are 99 numbers in between these two. So you can write any 32 numbers that is rational numbers. Like you can write 1111 by 100, 1112 by 100. So do you understand what I am trying to say is, this is the easiest way. Divide it, multiply it by 10 if you have a if you have to find a single digit numbers, and for 2 digit, divide and multiply it by 100. So this is the simple method. We will use this method to find the, if the question is asked to find a rational numbers between two numbers. There is also one another method for the decimals, like if I will write 1.1, 1.2, 1.3, 1.4. These also are rational numbers. Why? Because for 1.1 we can write it as 11 by 10. For 1.2 we can write it as 12 by 10. 1.3 13 by 10. So this is also one method to find the rational numbers between these. You have to give answer in this form, right? Now we will do an exercise 1.1. Now it is time to solve exercise 1.1. Right? The first question is 0 a rational number? We all know that 0 comes under whole number and whole number comes under rational number. So 0 is rational number, right? So the answer to our first question is yes, 0 is rational number. The another question in the first is, can you write it is in the form of p by q, where p and q are integers and q does not equal to 0? Of course we can write it. We can write 0 as 0 divided by 1 equal to p by q, where p equal to 0 is integer, q equal to 1 is also integer, and q does not equal to 0. So here is your answer. Remember one thing, write your answer properly in your exam, because that will give you a good marks. Now the second question, 6 rational number between 3 and 4. We have to find 6 rational numbers between 3 and 4. The easiest way is write 3 and 4. Now this is, I have to find 6 rational numbers, so I will multiply and divide it by 10, because that will become easy for us. So it becomes 30 by 10, it becomes 40 by 10. Now you can write any 6 numbers between these, like 31 by 10, 32 by 10, 33 by 10, 34 by 10, 35 by 10, and 36 by 10. Right? This is the 6 rational numbers that comes between 3 and 4. So our second question is also done. Now here comes our third question, and that is, write 5 rational numbers between 3 by 5 and 4 by 5. Here comes 3 by 5 and 4 by 5 fraction numbers. We don't need to get feared, right? Just write 3 by 5 and 4 by 5. See how many numbers we have to find. This is 5, so we will multiply and divide by 10, right? Then it will become 30 by 50, it will become 40 by 50. Write any 5 numbers between these, like 31 by 50, 32 by 50, 33 by 50, 34 by 50, and 35 by 50. These are 5 rational numbers that comes between 3 by 5 and 4 by 5, right? So this is first 3 question. Now fourth question is, we have given 3 sentences and we have to say yes or no. Now we will see the fourth question. So here is the fourth and last question of exercise 1.1, and that is, we have to state whether the statements are true or false, and we have to give reason also. The first is, every natural number is a whole number. Is it right or wrong? Natural number is n, whole number is w. We have solved this question many times in this lecture. Every natural number is whole number. The question is asked in this direction, so it will be true. So answer is true. Now we have to mention reason for this. The reason is, we will write it in the form of these whole numbers comes in whole numbers also. This is our reason. You can write reason in the any language or any sentence you want, but it should be true, right? Every integer is a whole number. We can write integer as z, whole number as w. Now go here. The question is asked that every integer is whole number. Question is asked in reverse direction. It will be false. So here we write it is false. Now why it is false? Because every integer is a whole number. So we in the reason we have to give one example that is an integer but not a whole number. All the negative numbers that comes under integer but not comes under whole number. So we can write any number like -3 is an integer, but -3 is not whole number. Here is the reason. You can give any example that is contradict the sentence. Now the third is every rational number is whole number. The question said that every people that are living in India also live in Ayodhya district. That is false. We also know. Obviously, now we have to give a example that is a rational number but not a whole number. You can write that 3/2 is rational number, but 3/2 is not a whole number. So here is your answer. You can give any example that you want that is a rational number but not a whole number. The same sentence that I have written, the same reason that I have written in the second question can also be written in the third question, because negative numbers is a rational number but it is not a whole number, right? So here is our exercise 1.1. The type of question that will be asked from these concepts are this type of sentence questions, right? And the another is to find the rational numbers between two numbers, right? We will keep this lecture till here. Now in the next lecture we will learn about some new concepts, and that is irrational numbers, and we will do exercise and example related to this. Thank you for watching this.